Hello everybody, today's topic is Project Gemini, which runs from 1961 to 1966. It is the second part of the U.S. space program. So what is Project Gemini? Well, it's going to be a set of two-manned missions, and the entire point is to create the capability and technologies necessary to get to the moon. So JFK, near the end of Project Mercury, came off the speech that we would land a man on the moon and return him safely by the end of the decade. So now NASA has a bigger goal. Not only do we need to get to space, but we need to get to the moon and back. So the space race is on in full time now. We need to simulate the length of time necessary to travel to the moon and back, so we get to have manned missions that are up in space longer. We need to attempt an EVA, aka we need to get men to leave the space vehicle for the first time ever. And we need to develop the technologies of rendezvousing and docking in space. These are major feats. These are going to be major milestones in Project Gemini. We also need to use a bigger, more powerful rocket. It's going to be the Titan II GLV. GLV stands for Gemini Launch Vehicle. This is a two-stage rocket, and it has less moving parts. Because it has less moving parts, it's less likely to fail or blow up on the launch pad, which is all good. Gemini 1 and 2 are unmanned missions. If we're going to test a new rocket, we're not going to put a human being on board the first time ever, because what if the rocket blows up? So these unmanned missions are going to test the capabilities of the Titan II rocket. The Titan II rocket is going to use a new type of ablative heat shield. So it's going to be a new type of resin with carbon fiber. Ablative heat shields are one-time use. So basically the heat energy hits the shield, and then the shield starts to break away. And as it breaks away, it takes that heat energy away with it, keeping the inside of the capsule nice and cool. We don't want to burn up the astronauts inside. We're going to also use a new tracking and communication system, because if we're going to rendezvous and dock in space, we need to know exactly where they are, and they need to be able to talk to one another. So now let's get to Gemini 4. I'm not going to go over every single Gemini mission. Gemini 4, the important milestone is that Ed White, he EVAs for the first time. Now, this was almost like a secret mission. When they were up in space, if everything was going good, then they would announce it to the rest of the world that we are going to EVA. Now, we are not the first person to EVA. This is the first American EVA. The Russians beat us to the EVA by several weeks again. So at this point in time, the Russians are currently still winning the space race, but don't worry, U.S. is going to catch up, and we're going to start winning very, very shortly. While he EVAs, he is going to be attached via a rope while he's outside. Remember, space is very, very cold. Ed White, he was like, it's so cold in here, but this is an amazing view. So he was out there for quite some time. And so I also put on this slide who the first actual Russian cosmonaut to EVA was Alexei Leonov, and that was, once again, almost several weeks before us Americans. Now let's get to the part where America finally starts to win during the space race. We got Gemini 6 and 7. It's going to be essentially the first rendezvous in space. Rendezvous means meeting up. So technically, Gemini 7 will launch before Gemini 6. Gemini 7 has an additional mission of extended space duration. They're going to spend 2 weeks up in space. Then we finally have Gemini 6. Gemini 6 was supposed to launch like 3 days after Gemini 7 and then meet up, but there was a malfunction with the rocket, and so the mission got delayed by a couple of days while they did their fixes. But luckily, the fix did occur, and they didn't end up going in space and meeting up for the first time. Now, these objects, if you think about it, they're traveling very, very fast. Space is very dark, so we have these new communication and tracking systems for the Gemini missions, and they're at use now. So we finally start to win. So once again, the Russians, they don't have this capability yet. Now, let's continue on with the Gemini missions. So we finally met up with the target with Gemini 6 and 7. So now not only are we going to meet up with the object in space, we are literally going to dock. And so Gemini 8 primary mission, some of you know Neil Armstrong. So Neil Armstrong's mission's here. He's the pilot. He successfully docks with the mission, and they noticed something started going wrong after they did the docking. So primary mission success. However, they begin to rotate. Everything outside starts going faster and faster and faster. Neil, he takes the helm and he uses a thruster to go the opposite direction. So you have two thrusters using lots of fuel, and they're going in opposite directions. As the fuel level comes down, it gets to critical level, forcing mission abort. But the primary mission was successful. So this is the first mission abort in space. They also are the farthest to land off the initial landing zone. Here is a picture of how you would dock with a Gemini target vehicle. You can see the GLV in the very bottom of the image. You got two people aboard. As it's coming up, it's communicating. We got radar lock, it's communicating, radar lock, communicating, and finally you meet up in space. So both these objects are traveling very, very fast. You want to slowly dock. You don't want to hit the object at like difference of like 100 miles per hour, because that would be like a car crash down here up in space. That would be devastating and you would die. So this here is a major feat, major milestone. Let's continue on. We got Gemini 9. This is complete failure, but they do survive. Essentially, their goal was to target vehicle again and dock. They fail. So they go to their next mission to use the jetpack for the first time ever. And so he EVAs, Cernan goes outside, and he's like trying to swim in space. He's like fighting the microgravity out in space. And so his heart rate starts to go up. He's not successful. He only has like a rope there, nothing to hold on to, and so he can't get to the back of the launch vehicle to grab the jetpack. Well, his fog, like all of his sweat, fogs up his visor, and you can't see. His heart rate's going through the roof. And so the doctors on the ground are like, yeah, mission abort. So they come back down with complete failure. But we do end the Gemini missions with complete success. So Buzz Aldrin, he's like, you know what? All these training programs you down here, using this crane, using this rope, us walking on the side of walls, that's not simulating outer space. So he comes up with zero buoyancy training, also known as underwater training. So he uses his diving experience. And so Buzz Aldrin, he does like 3 different major activities during his EVA. And he's like, yeah, this is even easier than when I was doing it down here on Earth. He uses the microgravity, essentially zero gravity, to his advantage instead of as a detriment. So he ends the Gemini mission with complete mission success. So now we have the technologies necessary to start to get to the moon.